everyone, welcome to my presentation. I'm Matti Tahvonen, I work at Vaadin, and at Vaadin we make web applications. The topic today is about optimization of web apps, but I guess the principles that I'm showing here, they would fit for any kind of apps. And as an example, I'm naturally using our own product, so you will see how bad our product is in some cases. But the main point is not Vaadin here. It's optimizations. When you should do it, how you should do it, and how you should figure out what to do it. And I guess how many Vaadin developers do we have here, or who knows what Vaadin is? Okay. Minority still, yeah, but quite a lot. If there is somebody who happened to be at our last year's or last autumn's community meetup in Vaadin Create, this is basically the same presentation as there. So if you want to change the room now, there's probably nothing new to you in this presentation. But I will do a version of this presentation here now so that you can follow it, even if you are not a Vaadin developer. I like to call myself these days code artist, and that's because I think software development is quite a lot like you need creativity there. You need to, if you want to write good code, it's usually more about figuring out good naming and good structure to your code. So it's not that much about engineering, but when we are attacking performance issues, then you should be the engineer. Then you should be looking at the numbers and not how it looks like the code. I'm actually also a pro bono endurance coach. I have a couple of athletes who I try to optimize. I try to make them run faster. Apparently the conference Wi-Fi should be optimized as well, so we cannot see the video, but basically this fellow, Daniel, should be running there fast. And this is a test that we do usually like a couple of times per year. So we increase the speed steadily, and then we measure a lot of different data. And then we know how the body functions under the load. And this is something that you should be doing as well when you are optimizing, and also figuring out if you should optimize and what you should optimize. So when I work as an oriented coach, then usually I look the numbers much more than when I'm coding. In coding, usually I look numbers only if I have to optimize. So basically, I'm more like an engineer when I'm coaching than when I'm writing code. And I have seen that there is a tendency in developers to do the same, so I think I'm not the only one. I have a colleague, we can call him Vesa, but the name is of course changed. He has a hobby called electricity. So he has electric car, he has solar panels, and then he has an electric contract with hourly pricing. So the price changes 24 times per day. And when the big war in Ukraine started, there was a kind of a electricity price crisis. I think it was here as well, but especially in Finland we had it. And it became very popular to optimize your electric bills, especially with this kind of special contracts. And Vesa, of course, needed numbers here. He found his engineer with this hobby. He's also a code artist. I have seen that because he made a mistake with this application. He built it like in just a couple of days and put it to the internet because he thought that somebody else might actually like it as well, and it actually became quite a popular application. And at that time, there was a pretty nice free tier in Heroku that provided you free nodes that only contained 512 megabytes of memory. And because he had a lot of data there, and because of how Vaadin works. I will show that to everybody in a moment. But because of that reason, the server actually started to collect quite a lot of memory for all of those active users that he had. And he got out of memory exceptions, and immediately he started to optimize. He made a guess. He didn't do the right thing. He made a guess that what he should optimize. He thought that, okay, it's the server-side state, and we have the data there. That's ruining the thing. And he decided, okay, I will optimize it with a front-end screen. He's a Java developer. He uses our Java product, and he wanted to also learn new things while doing that. So he directly jumped into implementing this screen that contained it contains the electricity prices. You can see that on the blue one, and then it shows wind production, nuclear production, whatever you want to enable here. Only three of these rows are enabled at the moment, but it contains a ton of data. And he moved handling of all that data to the client side, so he only takes that from the database and pushed it to the client side, made it with a front-end centric approach. But yeah, and then he deployed the new version, and he didn't ever look at the numbers, but the problem disappeared, and he was very happy that, yes, I succeeded. But what actually happened is pretty much here. It was not this time, but a similar case, that there was a peak in an electricity price, and there was a ton of users arriving to his application. And then when the peak went down, he published the new version, and he didn't see any out-of-memory exceptions anymore in the hierarchy logs. And he was very happy that, yes, I did it. And then there was another peak, and then it failed again. He didn't actually check that the fixes actually did the thing. He was not the engineer, he was only the code artist. He made a new code, and he was very happy with that. Let's look into this application that I built. It has a couple of views. It has first view is pretty much replication of this case that Vesa had. It has a lot of chart data. And then there are a couple of other cases where all of these bottlenecks are very different types of bottlenecks. And we will resolve it and figure out that what kind of tooling we can use to figure out that where is the bottleneck and what we should do to get rid of the issue. Sometimes it's actually fixing the issue, and sometimes it can be something that we do in the UI. Let me build the application and run it with very tiny amount of memory. So this application is now built with our framework called Vaadin Flow. And it's using Spring Boot. And Spring Boot and the database drivers and so on and all that requires quite a lot of memory to start up. So the heap size 23 megabytes is just enough to get it up and running. The database that it connects is running also in the same machine, but it's not relevant here. And this is the welcome screen. So quick intro to Vaadin. So basically, Vaadin is a server-centric framework. Vaadin Flow, especially. We have actually two frameworks in our product. In Vaadin Flow, everything is stored on the server side, and there is a framework that basically maps all the UI components to the Java API. So this part here, the one where we have like one text field and a button, is expressed on this view here. Can you see the code well, or should I zoom in? Okay, pretty good, I guess. So we have one text field that we are instantiating on the Java side. And we are adding that and a button to the layout, and then they just appear there. So Vaadin users never need to touch any JavaScript or HTML. And when you type in something to the text field, let's say Matti, this value now synchronizes to this Java instance. And in the click listener that we are defining here in line as a lambda expression, we can directly go to the value. We can get the name, and then we can do whatever we wanted it and modify the UI. So we are adding a new paragraph that contains the name coming from this text field. And this approach has, of course, pros and cons. The pro is very efficient UI development, especially for Java developers. So basically, you can forget everything that happens between the client-server communication and on the front-end side. You don't need to know any JavaScript or TypeScript or even HTML or CSS. You can go very far with poor Java. Of course, when you need to customize something, for example, create some kind of a custom component that is not in the built-in component palette, then you might need to create a new component with a lower level technology. But usually that's not an issue in business applications. The downside is, of course, that it's in the server memory. This consumes some memory because the button and the text field, they are in the server memory. So basically, now that I typed in here some text, if I now wait a bit while Vaadin synchronizes the content, there is more data in the JVM memory. So all the content that we have there on the screen, that consumes some memory on the server. Typically, it's quite little. It can be a couple of kilobytes. It can be a couple of 100 kilobytes if you have huge data sets like grids on the screen. And if you make some mistakes, it can be megabytes. In this case, if we go to this chart view, where we are loading a ton of data from the database, there is like 1 megabyte of memory from the JVM heap that Vaadin reserves. And I have a script. Actually, in the previous presentation, I did it with the audience, but I made a playwright script that is now running when I click here. So now it opens new browsers. It opens new browser windows, and it opens new browser windows as long as as they are basically loading. It should stop pretty soon because we have 32 megabytes of heap only, and now we have an out of memory option. The thing that Vesa should have done in the previous case should have been to investigate the memory consumption here in this state and figure out that where it is actually consumed, find out what to do with it, and then measure again when it's done correctly. And that's what we are going to do now. So I'm working at the DevRel, and I work at open source company, so I like to use open source tooling. So I'm going to use Visual VM here, but you could of course use something else as well. Basically, if you take the commercial version of IntelliJ, it has built-in profiler that you can use. Then there is JProfiler, which is very good. NetBeans has a profiler which is basically built with the same tooling that Visual VM has. So Visual VM actually it came with your JDK in the previous versions. Now you need to download it separately, but it's still pretty well maintained. I like to use it myself. So this is the jar file that is executing currently. And if you go to the monitor, we can see that we have all the heap space done. All is there. We cannot perform garbage collection anymore because it's out of memory, but we can take a heap dump. And then we can analyze the retain sizes. So basically calculate the object tree so that we can see that what is actually taking all that data. And if we sort by retain size, these are probably something else. These are related to probably Tomcat, but these state nodes, these are belonging to Vaadin. And we can see that there is also this chart configuration and chart data series and so on, but it's basically these components. So we can even see that there is these 8 instances of this chart component that is then referring this data series, and then we have a ton of these data series items and so on. So that was the problem. And the next thing is, of course, to go to the code and switch to the right project. And in the chart view, we can make a trick now. So there is a special version of this chart component. This chart component is, by the way, one of the few commercial components that we have for Vaadin. Everything else is open source. But this lie chart version is doing a hack here, which is basically releasing the memory. So even though Vaadin is a stateless framework, it doesn't mean that every component should always keep every data into the server memory, because the client-side component that we have here, this now already contains all the data. So we would only need this data in the server-side API if we would like to access it somehow during like from our code. If you want to add something there or do some, we want to get those data series items out of it and analyze it somehow, then we would need it. But in this case, it's already there, so we can actually forget it. I made a very quick hack for Vesa to this application where I'm just using rudely reflection because the implementation detail is private, and then I'm resetting this configuration field to null, and that's enough. It actually doesn't here I'm hooking it to some protected method, so then I'm calling this free memory, which is clearing it up. And now if I restart it, the functionality should be exactly the same. Okay, let's shut it down, make a new build. All right, so now we should have the chart view opening again. Same thing here. And now if we rerun the script, the hypothesis is that it will never end. So now even though we only have like 32 megabytes of memory and a server-centric UI framework, it should be fine to open like dozens and dozens of these windows. I think I have some kind of a logging in that script. So yeah, so now we are already at 13, 14, 15. It will not end during this presentation. Or maybe I will run out of memory here in... How do I close it? Oh, I need to be fast. I will probably run out of memory in this Mac because of so many Chrome browsers popping up and taking the memory. So sometimes you need to be quite creative when figuring out how to fix it, how to find it. But if you know where to find it, then you're already quite close. And the fixes, they are, of course, they are always there. You can use your creativity, but measure it afterwards. So now we actually have 21 windows open, and if we look it up from here, this is the new application, and if we look at the monitor, we can see that it's only 26 megabytes used, and if we perform garbage collection, it's even a bit less. So problem gone. The same thing also can be an issue, like reserving too much memory on of course on stateless applications, web applications as well. You probably have some caches, for example, that might consume a lot or most of your JVM memory, and then the performance will be worse. It can affect many different things and in quite surprising ways actually. Sometimes if you run out of the heap then you might run out of the available space for caches, and then you cannot serve as many users as before. So try to release all the memory you can. Let's open the application now from IDE and look into these other cases. This was the wrong. We can actually close this for now. I will now open the application right from the IDE. So now we have the normal amount of memory, whatever JVM happens to reserve. And we should have one user here, but let's now go to the salaries view. Here we have a totally different kind of performance issues. The screen is very slow. It's now trying to go to the second view, to the salaries, but it's loading and loading and loading, and finally we have the view here. This is a database issue, and that's probably the most common issues that we have. And we can verify that from the browser console or server-side issue. And usually this is where I start, because with the browser inspector, you can see it quickly. Is the issue on the browser rendering side or on the client-server communication, or is it in the JVM side? And then if it's on the JVM side, you will jump to different tooling. So now if we reload it, we can see this is now Safari's inspector. Chrome has pretty similar. This is in some way better, some way worse. We can see that it's taking the time. So there was one XML HTTP request that loaded a ton of data, and it took 12 seconds to load. And if we go to the timeline view, I should have been actually here right now. We can see that it's waiting and waiting. It's waiting for the network. It's doing nothing. The CPU is quite full, but this is because it's counting the CPU from the actual CPU usage. So it's basically the JVM or the MySQL database running on the same browser. And then the actual rendering is very fast here. So obviously now we need to go to the visual VM again. And now let's open this one. This is now the application, the JVM process that I started from the server. We can see that we have plenty of memory now. It cannot be a memory issue because we have gigabytes of memory. And we can actually see that it's using a lot of memory, but if we perform easy, now it probably drops quite a bit. But yeah, we should go to profiler. And the good thing about all JDK profilers that they can also profile the JDBC connections pretty easily. So now I have the JDBC profiling on, and now I go here and reload the page. And now I can see that there was one quite slow query that happened already, and then multiple other queries. So we have multiple issues actually on this screen. You could also see the you could also take the basic CPU profiling and see it from there that what is taking it long. But this is usually the first thing to do if you have a relational database. Check this screen, and if it's not, then go to normal CPU profiling side. Here you can see that what is actually initiating it. So this is coming from Yoku, and somewhere along the way we should see Spring Framework and our own view here. So this is our code, and this is what we can optimize. So it's the salaries view constructor. The first thing is obvious here. We are downloading the whole database into our memory. So this is bought in Grid, a bit more complicated component, but it has a very simple API. You can just provide a list of entities for it and define the columns, and then you're done. This is very nice thing and good way to do it if you don't have too much data. But in this case, we have thousands of rows there, and it will take a lot of time. So don't do this, but use lazy loading. So this is basically same as paging, if you happen to use that kind of approach, but Vaadin Grid comes with this kind of a seamless paging built in as a feature, and it is now in use. So instead of passing in the list like we did here previously, it is now using a callback method here. So we are getting this queue, which is query, and from the query we can get hints that what the grid component needs currently. So basically it now only fetches the visible rows on the visible rows that it needs for the browser, and fetches those from the JVM, and then the JVM makes a database query, and everybody is now consuming less memory. Previously, actually, in this case, Vaadin actually did some lazy loading already between the client and a server communication. So if you scroll down, it didn't have all the rows there. Now the server is down. But it only rendered these visible ones. But we did actually load them from the database and stored them in the JVM, but we didn't send them over the wire. But now, if we save it and reload, connection lost. Let's restart. All right, new try. Now it's still slow, but it was a bit faster. And now the issue is still there if we want to inspect it, but we can actually use these results as well. So it was not just this one slow query. This is now gone, but most of the time was going to these sleep queries that I put into my example code because the database connection was too fast. That's usually not the case in your applications. There, the database queries are usually the thing. You want to minimize them to absolute minimum. So don't go to the database all the time. If you need to load something to a component like this grid, try to make it so that you have like one query going to the database only, instead of making one and then fetching more data like we are doing here for this column. So we are now fetching from the same class more data dynamically here. So we go to the service layer again and fetch more details for this salary information, and then place it to a div component, which is basically just a div element here inside this grid. So the true fix here would be to write SQL, but because I don't like to do that, I'm more like a Java developer, I will show you another kind of approach how this can be solved, at least to some extent. This is not a proper performance fix, but this is now related to the UI. So sometimes, especially in a business application where your amount of users is kind of expected, you know how much there are people, and you know what kind of problems they have. Sometimes it doesn't make sense to get a database engineer to optimize the query, making the indexes or making the complex thing, especially if you happen to be a UI developer. This could be the same approach could be applied with JavaScript as well. So we should, instead of doing it in one batch, getting all the data and combining that, we should now first display something and then load more dynamically. So we will be using a progress indicator. And I have a handy helper method here where I can pass a task that will be executed later. And this will return me a progress indicator or progress bar. I will add that to the div instead of the actual data. This handy helper method actually also removes the progress bar once this task is completed. And then let's move this heavy thing here and hit save. And if live reload in Spring Boot works correctly, we should now have somewhat functional view. So now the view was very fast to render initially. So it made a page query to the backend, and it got the raw data here. Most of it was rendered immediately. It felt very responsive. And that's the most important thing that you should aim for, because then the user doesn't need to think that it's broken. It's now, to get all the full data, it's just as slow as in the previous step, but it feels faster because it doesn't look like it's broken, and the user gets the indication that it's still loading more data. So use progress indicators. That's a good way to cheat, and a good way to avoid optimization in some cases, because optimization is expensive, and this was very quick trick. Okay, let's check out the third example that I have here. This is again very different kind of problem, and again we should be starting from the browser inspector. So we can go here. So now it's automatically initialized. This screen is actually, for some reason, very slow in Safari. It's also slow in Chrome, but super slow in Safari. The reason this time is actually in one of these components. So it took around 8 seconds to render. And if we go here, we can close it. Close the recording. Let's actually use Chrome here, so that you can see that there can be pretty large browser differences in performance issues as well. So this is now Chrome, and it renders in a bit more than 1 second. That's kind of a bit too much already. You should probably show the progress indicator that it's rendering here, this area now, but it's quite okay. But in Safari, it's unexpected. And the issue here is this rich text editor. For some reason, especially in Safari, it makes views very slow. So this is now containing 80 different instances of this rich text editor. It also contains Vaadin Grid and Vaadin Date Picker, which are also quite heavy components, but they render very fast if you have, even if you have this much data on your screen. But then when you have these rich text editors, it becomes way too slow. You could find it with inspector here, that what is the exact component. You cannot do it with Vaadin very easily. You need to first compile it in the development mode, because I happen to be running in the production mode here. It's basically gibberish, and it's often the same situation with any front-end centric technologies. So if you want to inspect this kind of problems, then you probably should disable minification in your front-end build chain. So go to the webpack config and do the configuration so that you have like reasonable method names when you try to inspect the data that you get from the browser inspector. But I'm not going to bore you with that part, but to present a solution, because fixing this kind of very complex component wouldn't be a solution in any business applications where you have a lot of other things to do as well. You cannot take this one component and expect that you can get that fixed in a reasonable time. It probably requires help from the actual maintainer of the component and so on, and it will take ages to get it fixed. So it's better to do another hack in the UI to make the UI actually responsive and good for the user. And this is probably a trick that you have been using yourself in applications, but not necessarily implemented in your own applications. And the trick is it's basically the same that we had here on the salaries view, done automatically by the warning grid. So here we lazily load only the rows, like the relevant data that is needed for this size of a screen. So we should only render part of these UI components that are in this department, and then render more if we scroll down. So let's take this one. I need my glasses, it's so dark. This is the part. So this is the part this is the value change listener, where we get the new result set for that department, and then we are rendering that into this result component, or no, not this employee layout component. And there we have a scroller, which is basically giving us this scroll bar so that it doesn't scroll the whole screen, but only this result part. So instead of rendering all, we can start by trying out what would be a suitable number. So let's not render everything, but let's just render, for example, five top results. This is probably actually broken because there might be 0 results as well, but with this dataset, we know that there is 80 of those. Now, even in Safari, it's basically instant. So we have it on the screen immediately, even though it has this nasty performance issue. But with 80, it was 8 seconds. But now we need to load more. So now let's do the same thing that Twitter is doing, or whatever they call it these days. So let's actually assign that next to render variable into a field. And then we want to always start from the 0. And we want to have math min from results. That's our result set. So to the max result or next to render plus 5. And last. Last. And now let's replace the 5 with that. And now we need to call this from 2 places. So let's quickly extract this into a method. Load more results. Good naming. And then we need to hook a listener to the scroller. So here we can add scroll to end listener. So that happened to be available. And now execute the same load more results. I don't have the results. They are supposed to be saved into some variable as well. Yeah, let's remove that parameter from there and there. Yeah, so we are saving it here to the field already, so no need to pass it around. So now we should have basically the same UX for the users, but it should be fast. So now we loaded it in 162 milliseconds, and if we load to the end, it loaded more. So now we have the 6th, 7th, 8th, and even more. It goes all the way around, and it never chokes the browser now because it renders only the new ones that we get from the server side. So the user doesn't need to be frustrated. Of course, if they want to scroll to the last one here, then it's not very handy because then they would need to wait for several times in a row to get new rows and so on. But you can fix that with a UI. So you can add sorting, filtering here. You can have a button even to scroll to the end and then just render the last ones and leave the first one unrendered. Takeaways. Yes. Be the engineer. Use the numbers. Always before jumping into these interesting optimization problems, take the numbers in the beginning, find the bottleneck, try to fix it, then repeat it somehow. You might need some tooling. I was using here like end-to-end testing tooling just because I wanted to get it visualized so that you can see that how the browsers open. But most likely you will need to use Kotlin or JMeter sometimes to load some artificial traffic to your application under the development. Or then instead of profiler, you can use also observability tooling. So this is quite common these days that you can get same kind of insights from a production deployment as well. But the thing is that you need to get the numbers also after the fix. It's very easy to think that yes, now it's resolved without actually proving it. And don't stick into the idea that you need to fix the actual performance bottlenecks. Sometimes it's very expensive. It might be like weeks of engineering to get it optimized well enough, and it might be you might need a lot of memory for some caching, for example. Sometimes you want to make some hacks or workarounds in the UI, but make them so that the user doesn't need to wait at any point. Lazy loading, releasing memory, and probably the most important thing to remember is that the database, that's usually the issue, either the database itself or the connection between your JVM and the database. So check that first. Usually you will see that that's the place to optimize. And yes, pray for forgiveness. So these couple of hacks that I showed in the UI, they usually are enough, and they are way cheaper to implement than to spend your time optimizing the SQL queries. We have spent most of the time, but I think we can get some questions as well. There was this new system that you can type in your questions, or then if you don't like mobile phones, then I think we can do it in the old-fashioned way as well. Let's see if this mobile works first. Probably not. Okay, let's take a...
One question, this pagination. So you loaded all results set to the memory, or you have executed the new query to the database?
Yeah.
The pagination.
Yeah.
So, and what happens when you have multiple users with the different filters selected and trying to do pagination? What happens?
Yeah, so the question was about pagination, and this was probably more like to figure out that how Vaadin does the pagination.
I wondered where do you keep the
Yeah.
records? So do you keep them in memory, or you are just pinging database for each request?
Yeah, so here in this case we have only like grid, so all the users, they basically see all the same data. But in a real life scenarios, like you mentioned, you usually have some kind of a filtering there. You might select only some section from the company, or you might have some free text filters to the query. And in this kind of case, it's still the same. So you want to paginate the result set. So you need to store the queries. So in this case, this is also not Vaadin specific, but with the Vaadin listing here, it would be this place that we would need to replace. So currently we are just dumping the data here in the constructor, but this would need to be replaced into a method. And then you would have this text field component, for example, that we had in the main view that could be used for filtering. And then for that text field, you will add a text change listener, and when that text changes, then you go to the database again to get new results. So you could, of course, try to optimize. Well, you couldn't, especially with this big data set. You don't have, now that we did the optimizations, we only have those first 50 rows in the JVM memory, and you cannot know if the next rows could match your criteria. So that's why you need to go to the database again.
I wondered because I was facing a similar problem on one of my projects with large amounts of data sets. We wanted to speed things up, and I just wanted to see how the way it works.
Yeah.
I haven't worked with it.
Yeah. So this is kind of, I had the caching in my key takeaway slides as well, but caching becomes much more difficult if you have this kind of filters for your big data set. So then you don't have a way to basically cache those from different users. So because the different user is for sure gonna use different search string there. So there the caching doesn't help that there. Then you just need to make efficient queries. We are pretty much out of time. I don't know if we can take another questions. 2 minutes, so we can have one more question if you want. There you go. Yeah, one specific question, I will repeat it quickly, but yeah, there was this quick hack that I showed on the chart component, where I'm doing a very dirty hack. I will open it here. So it was this slide chart fix. So here, when I'm freeing the memory, because the field was not protected, so I couldn't override that class and just make it null there. So I was using reflection here, and the question is that is it suggested way? Well, that's the suggested way if you don't have any other solution available. Yeah, probably the right way to do it would be to give feedback for our engineers. So create an issue to GitHub that we would like to customize this part of the application. We don't, when we develop the components, we want to have this open close principle that helps our development team to stay agile and delivering also new features. Because if we would basically open every internal things that we have in our components by default, people would be using all of those and in very unexpected manners. And then whenever we change something from the implementation, that would break dozens of applications out there. And that's why we have them closed. So do this, but be prepared to fix it when the new version comes out. But yes, give the feedback that this would be good to have some kind of a method to override or release. That's the preferred way, but that might take some time. So, and I would say that this is not a one specific question. Probably applies to every UI framework. Okay, let's cut it here, and thank you.